Let us understand the concept of free fall in this session. Whenever we hold any object in our hands, we should remember that there is a gravitational force acting on the object. But then why does the object not fall down? It is because we are applying one force on the object in the upward direction. This force balances the gravitational force. Both the forces cancel each other, so the object remains in our hand. Think about it. You carry any object in your hand, there is a force, that is a gravitational force which is acting on it. But you yourself are applying one force in the upward direction. Both these forces cancel each other, and so the object remains in your hand. What happens if you release this object? Then the object will fall down due to the gravitational force. There will be an acceleration in the object, which is acceleration due to gravity. Whenever an object falls under the influence of gravity alone, we say it is experiencing a free fall. So whenever an object moves under the influence of force of gravity alone, it is said to be falling freely. So in a free fall, the initial velocity of the object is zero, and it goes on increasing due to the acceleration due to gravity. But when we do this experiment, in reality, around us, we see that there is frictional force due to air, and there is a buoyant force which acts on the object. So we cannot see true free fall in nature. True free fall is only possible in vacuum. Think about it. You leave an object to fall. You allow an object to fall. The object falls under the influence of the gravitational force. Let's see how the equations of motion change when we apply the concept of free fall. Now, we know that there are three equations of motion. The first one is V is equal to U plus AT. Now what we do is, since U is 0 meter per second and acceleration A is g, we substitute the values, we get V is equal to 0 plus gt. So our first equation is transformed into V is equal to gt. Let's have a recap. V is equal to U plus AT, U is 0 and A is g. Therefore V is equal to 0 plus gt, so E is equal to gt. Let's check out how the second equation is. Second equation of motion is S is equal to ut plus half at square. Again we substitute U is equal to 0 and A as g. So we get S is equal to 0 into t plus half gt square. That will be S is equal to half gt square. So what did we do? We substituted U is equal to 0 and A is equal to g, and we got S is equal to half gt square. Let's move on to the third equation of motion, that is V square is equal to U square plus 2as. Again here U is equal to 0 and A will be g. So A will be g, so we get V square is equal to 0 square plus 2gs. So we get V square is equal to 2gs. So you see the concept is the same. U is equal to 0 and A is equal to g. This is the substituting part which we have done, and we get V square equal to 2gs. So coming back to our book, it is mentioned very clearly that the three equations of motion are v is equal to gt, s equal to half gt square, and v square equal to 2gs. Now a very important point which you have to know is that, as you can see, I have circled it as minus g. Whenever an object is thrown upwards, acceleration is negative, that is in a direction opposite to the velocity. Therefore it is taken as minus g. The magnitude remains the same, but the velocity of the object decreases, and we know when the velocity decreases then there is negative acceleration. Therefore it is minus g.